So we have the pads that we need for our part, the Arduino, with the 12 pins on each side. Um, Now we need to create a footprint, so these two rows would fit into that footprint, and that footprint could be on the PCB, so you can mount it directly, this part directly onto the PCB and solder it, but then it would be difficult to remove it. Or you can place a socket on your board at these positions, and so that you can plug in your Arduino into your PCB. So it's the same. The footprint should look the same because the dimensions are the same. So if we look at this part as a whole, the distance between each pin is 0.1 inches. So we need to convert that into millimeters. And the distance between these two pins is 0.6 millimeters. So between each of these pins it's 0.1, and horizontal distance is between these two pins is 0.6 millimeters. And it depends where we want to put the center of this part. So I would take the center of this part to be the center of the footprint, and design accordingly. You can also choose the first pin, for example, as a center, but yeah, it's your own choice. But I think it's better to choose the center of the part, which is almost here, as the center of your footprint. So in order to design the footprint, we open PCB editor, and the easiest way to start a new part is that you select open, and then you have you go into your directory, the one that we've been working with, here, Allegro, to PCB defaults, and there is you have to select here drawing symbol drawing, which is the footprint. The names are used interchangeably. Footprint and symbols have the same, are synonyms, so they're the same. We have here default symbol millimeter, and just open this. It's empty. You can zoom in and out using these magnifying glasses. There is no pin here. So the first thing you do is you hit File, Save As, and instead of PCB defaults, you choose OrCAD Video Lecture, and we name the footprint Arduino. Make sure that you have .dra selected here, and then hit Save. By doing this, you don't have to go through all the settings. So if you have this file available to you, it's best that you create your part using that file. Alright, so now we need to start placing the pads here, and how we do that, the first thing we do is select this add pin, make sure this is connect, pad stack. Okay, I forgot this. Before we do that, you have to add that folder into this environment. And how you can do that, you can go into setup user preferences, and then you have here something called paths and editor, no, library, and you have to select the pad path here, which is your directory. So we can you can hit here new and then browse, and you have OrCAD video lecture. So okay, so that folder is added. Make sure that this you do this before, because otherwise it will not recognize the parts or the pads. And also the PSM path, which is the path for your symbol. So we add a new one, and the same goes with this one, OrCAD video lecture. Okay, so once you have done this, you hit OK. And now if you click here, you should be able to see the pad that you created, which is circle 1.4 millimeter, drill 0.9 millimeter. Okay, and then hit OK. So we are going to place 12 pads in the y-axis, along the y-axis, starting at pin number 1. The spacing between these pads is 2.54, which is in millimeters, which is equal to 0.1 millimeter, as I said, 0.1 inch, as I said earlier. So this distance is 2.54 millimeters. All right. Okay. Let's see. Let me go back. Okay, so the order is down, which is okay. The offset is this should remain the same. Now we need to place this pad on the right at the right point. And what is that point? We have to calculate that. So like we saw in this picture, if we select this as the center, this point is 5.5. So it's 0.55 inches, 0.55 inches from the center in the x direction, and in the y direction it's 0, 1, 0.1, 0.2, 0.3. It's 0.3 inches. So we have to convert 0.55 inches to millimeters, which is 13.97 millimeters, and we have to convert 0.3 inches into millimeters, which is we can see how much that is. So let's see now. So I have all the settings ready. I click here in front of command and start typing X space minus I have to do this 2.54 into 7.62. So minus 7.62 and then 13.97, and then I hit enter. And what you can see now is that at the distance, this is the center, so at the distance of 7.62 millimeters and 13.97 millimeters, so this is the coordinate of our first pin, the center, and this is what has been created. And you can see that this is at the center of these points. The origin is at the center. So for the rest of the pads, I do something similar, Y, but this time up, and make sure that the pin is pin number 13 now, because you have placed already 12 pins. Make sure that this is correct. Yeah, the remaining you can leave the same, and then you click here in the command, in front of command, and start typing X, and this time instead of minus 7.62 you have 7.62, and instead of, you have minus 13.97. So why the minus? Because this is our origin, which is 0. So in this direction you have minus x, to the right you have plus x, to the top you have plus y, and to the bottom you have minus y. And since we are going to place our pad starting here, where you can see my cursor is, this is plus x and minus y. That's why I have typed in minus 13.97. And this is up, which is correct, and then we hit enter. So now you can see that you have 24 pins, 12 going down and 12 going up. Okay, and right click, done. So now the footprint for our Arduino has been created, which consists of 24 pins, and the distance between these two pins is 0.6 millimeters, 0.6 inches, and these are 0.1 inch or 2.5 millimeter apart. So there is your part. Hit save, and now it should be there.